Okay, so these are Regents review questions. These are all short answer. And you are going to need your reference tables, possibly calculator, and the kind of tying thread with all of them is the phrase in terms of. Your answer has to talk about whatever it says in terms of. Even if the answer is correct, if you don't speak in terms of whatever they want, you can't get credit. Also, what I would recommend is you keep it short and sweet. If you can get it done within a sentence or a couple words, you're good. You don't need to write a master's thesis on it. Okay, here we go. Base your answer to the following question. The formula below represents a hydrocarbon. Okay, here we go. Explain in terms of carbon-carbon bonds. So you have to talk about bonds between carbons, why this hydrocarbon is saturated. So saturated means all single bonds between carbons. So all single bonds. But that's a D. But that's kind of vague until you say between carbon atoms. So you got to say single bonds between the carbon atoms. All right. There are only single. I'm reading the answer key. There are only single bonds between the carbon atoms, and yeah, single. You could say single covalent. Well, you didn't really need to. Okay, you've got a balanced equation. Explain in terms of electrons why the bonding in NaCl is ionic. So if you were to say metal and nonmetal, that's not going to give you credit. So you can say NaCl is ionic because in terms of electrons, electrons are transferred. You can go a little bit more specifically and say, Na transfers electrons to Cl, but you didn't have to. You just had to say electrons are transferred. You could not say metal and nonmetal because you had to have electrons. Okay, we've got another formula. In terms of charge distribution, why it's polar. So in terms of bond distribution, a polar molecule would be asymmetrical. That is not spelled right. Asymmetrical distribution. You had to talk about the charge, though, so you could not just say the symmetry is asymmetrical. You had to talk about charge distribution. So asymmetrical distribution or unequal charge distribution. In either case, you have to mention charge distribution. Okay, voltaic cell. When the switch is closed, electrons flow. The diagram below represents the cell, etc., etc. Okay, you got this whole big thing. You got the balanced equation right here. State in terms of energy why this cell is a voltaic cell. Okay, so I know that this is a voltaic cell because chemical energy is transferred. Not transferred. Converted to electrical energy. And you can say this is a non-spontaneous, sorry, that's wrong. It is a spontaneous reaction. Spontaneous reaction. And no outside source of energy, like a battery, is required. So in terms of energy, why is it a voltaic cell? So you couldn't say it has a salt bridge, it has a voltmeter. You have to talk about energy. The energy changes is good, and you don't need the outside energy source. Okay, state in terms of molecular polarity why ethanol is soluble in water. So likes dissolve likes, which means that similar polarities dissolve in each other. It's not enough to say likes dissolve likes. Explain what that means and explain how that has to do with molecular polarity. You could say they are both polar. But it also, I mean, you could also say they have similar polarities, and that's probably the best, because what if you forget? You say, okay, well, are they both nonpolar or polar? So just say similar polarities dissolve in each other. Okay, fireworks contain metallic salts such as sodium, strontium, and barium, and they can generate bright colors. A technician investigates which colors are produced by the metallic salts by performing a flame test. During a flame test, metallic salt is heated in the flame of a gas burner. Each metallic salt emits a characteristic colored light in the flame. Explain in terms of electrons how a strontium salt emits colored light. So this is the bright line spectrum. We have to talk about electrons. So electrons gain energy through heating. When they release energy, light is given off. That's really messy. I apologize. So you don't have to talk about energy states, ground, and excited, but you do have to talk about electrons. Electrons gain energy, and the electrons release the energy, and light is given off. Let me read what the answer key says. When strontium electrons in an excited state move to a lower state, energy is emitted. Energy is emitted when electrons in higher energy shells move to higher to lower shells. Yeah, you just have to talk about the electrons, though. Explain in terms of electron configuration why arsenic and antimony are chemically similar. Antimony. Okay, so AS and SB. Let's go to periodic table. And I do apologize that we're going to have to look at it sideways. AS is here. SB is right below. Notice they're both in group 15. So you have to talk about them in terms of electron configuration. So if you say they're in the same group, and elements in the same group have similar properties, that's not enough. So what you could say is, here we are in the same group, and I'm going to erase this now. They all have 5 valence electrons, which I know super hard to read sideways, but you've got a periodic table. So same group, which means they have the same number of valence electrons, which means they have similar properties. So because they are in the same group, they have the same number of valence electrons, and that gives them similar properties. You could also say they both have 5, but you could just say they have the same. Okay? All right, part 2. Oh my gosh, it shows up again. Why did they have similar chemical properties? Again, talking about electron configuration. So, same group, which means we have the same number of valence electrons, which means you have similar properties. And I guess this is good, because what I did was I just went through the test software, and I just downloaded a whole bunch of in terms of questions, and I'm glad you're seeing some repeats, because you will. The more you practice, you're going to see the same kinds of stuff. Now, earlier it asked why something was an ionic compound in terms of electrons, but now it's asking in terms of element classification. So why is potassium oxide ionic compound? Because we have metals and nonmetals combining. So we don't actually need to talk about electrons. Yeah. In terms of bonding, why the hydrocarbon 2-methylpropane, which is this one, is saturated. So in terms of bonding, saturated means all single bonds. Okay, and you could also say they have no multiple bonds, but that's good too. The unique odors and flavors of many fruits are primarily due to small quantities of a certain class of organic compounds. The equation below represents the production of some of those compounds. which technically you don't need to have that knowledge for this reaction, but if you're using table R, you could know that this is an alcohol, and this is an organic acid, and this is an ester, and of course this is water. So this is an esterification reaction. You did not need that information for this question though. It says, in terms of molecule polarity, why reactant 2 is soluble in water? Reactant 2 is right here. Okay, well, I know that likes dissolve likes. And what that means is that they have the same polarity. Now, if you felt same polarity will dissolve in each other. So if you notice that, they're both asymmetrical, which is true, so they're both polar, that's great, and you can go ahead and mention that. But if you didn't know that they're both polar, you could just say similar polarities will dissolve in each other. Okay. Explain in terms of bonds why energy is absorbed during this reaction. So you cannot say energy is on the reactant side. That's not enough because it doesn't talk about bonds. So you can say bonds are broken and energy is absorbed. Because you've got O2 and then you had 2 singletons. All right. Another one of these charge distribution. If you are a polar molecule, you would have asymmetrical or unequal distribution of charge. Yeah. Okay. An atom in an excited state has an electron configuration of 272. Explain in terms of subatomic particles, which is protons, neutrons, electrons, why this excited atom is electrically neutral. Oh, okay. So, which ones have charge? Protons and electrons. So you can say protons, the number of protons equals the number of electrons. You could also say, well, there are 2 plus 7 is 9 plus 2 more, which is 11 electrons. You can say there are 11 electrons and 11 protons, but you don't even have to be that specific. You can just say the charged particles, which specifically are protons and electrons, would have to have the same number. Okay. So here we go, last bit. Sorry, I've got gum. I think I'll get rid of it. It actually doesn't ask you to graph, but you certainly could. Notice the y-axis is electronegativity. You want a scale that fits the whole thing. Okay, so I'm just looking at the chart. I see atomic number. Oh, those jerks. They don't go in order, so I guess we do have to graph. Well, let's see. 1.6 for 4. Let's see. You can watch me graph. It's boring. 1, 2, 3, 4. Yeah. Call that 1. Let's go up by 0.5. 2, 3, 4. Okay. All right. So 4 is 1.6. So here, they always ask you to circle and connect. 5 would be 2. 6 would be 2.6. 9 would be 4.0. 3 would be 1. And 8 would be 3.4. So again, circle and connect the points. If you've got you won't necessarily have a ruler, but straight edge, something like, I don't know, this. Okay. So there it is. You can clearly see it now. And yeah, they did it out of order just to get you. So, make it harder. Make sure you do graph it. State the trend in electronegativity in terms of atomic number. as atomic number increases, electronegativity also increases, right? Yeah. Naphthalene, a nonpolar substance that sublimes at room temperature, can be used to protect wool clothing from eaten by moth. This is mothballs. Explain in terms of intermolecular forces why naphthalene sublimes. Okay, why? First of all, sublimation is solid straight to the gas. And the reason why, is because it has very weak intermolecular forces. To go straight from solid to gas, it's like super, super weak. So it sublimes due to that. If you had stronger forces, it would stay solid. Explain in terms of atomic structure why why germanium is chemically similar to silicon. Okay, so germanium is Ge and silicon is Si. So guess what? They're probably in the same group. Silicon, where are you? Okay, same group. Same number of valence electrons. So when it talks about chemically similar atomic structure, you'd have to say same number of valence electrons. If you wanted to be specific, you could say they have 4 valence electrons, but you didn't have to. You could just say same number. Okay, we got another equation. In terms of electrons this time, why is NaCl ionic? So a transfer of electrons from Na to Cl. If you weren't sure if it went from Na to Cl or Cl to Na, you could just say there's a transfer of electrons. Okay, we got a reaction. It's at equilibrium. Explain in terms of energy why the forward reaction is exothermic. Well, you can say things like the forward reaction is this way. You can say energy is released. You can say energy is a product. If you were thinking about the potential energy diagram, you can say the PE of products is less than, which is right here, is less than the PE of reactants. Yeah, so any of those work as long as you're talking about energy. Okay, base your answer to the following below, which relates to the number of neutrons and protons for specific nuclides of carbon, nitrogen, neon, and sulfur. Okay, so a graph was done for you. This line connects points where the neutron to proton ratio is 1:1. So there's that. And we have blanks in this chart, which I don't think we actually need to fill in. It's talking about sulfur 32. Sulfur 32. So sulfur 32 has 16 neutrons and 16 protons. So 16 and 16, there it is. That's not a straight line. But notice how it's right there. Which, of course, I circled it a billion times. Oops. I circled it a billion times so that you can't see it. So I'm just going to erase that. Notice that it's right on that line. The line that says the ratio of protons to neutrons is 1:1. So in terms of atomic particles, why is it stable? The proton to neutron ratio is 1:1, making it stable. The more unstable it will be happens when you've got way more neutrons, making it super heavy. Okay, we got a chart. Just so you know, we have it filled in. Mixtures can either be homogeneous or heterogeneous, and substances can either be elements or compounds, although that's not what it's asking. Explain in terms of particle arrangement why NaClAq is homogeneous. So you got to talk about particles. So you can say the particles are evenly distributed. You can say the particles are uniformly distributed. Yeah, uniformly mixed. Something like that. You cannot say NaCl is aqueous because that does not talk about particles. You have to say all particles are evenly distributed throughout. An atom in an excited state has an electron configuration of 272. Did I have this earlier? Sorry, I think I did. Why is it electrically? I did have this earlier. Number of protons equals number of electrons. Same number of positive and negatives. I think since it's saying subatomic particles, though, you really should talk about protons and neutrons. So maybe that second part isn't so hot. Answer key says the atom has 11 protons, 11 electrons, or the same. 11 protons and 11 electrons. So you really did need to mention protons or electrons. And by the way, I was getting sloppy. This is P superscript plus. In a laboratory, a student makes a solution by completely dissolving 80 grams of KNO3 in 100 grams of hot water. The resulting solution has a temperature of 60 degrees. The room temperature in the lab is 22. Classify in terms of saturation the type of solution. So you have three options. You have unsaturated, saturated, and supersaturated. So depending on what probably table G tells us, we're going to need to use one of those three terms. So let's see, KNO3 at 80? No, I'm sorry. No, 60 degrees Celsius. So table G. Oops. Table G. Let me clean this up. Get out of here. Something old I was working on. So table GK NO3 at 60 degrees. 60 degrees. And it said I had 80 grams. Okay, so here's my data point. I'm making it really dark. And KNO3 is right here. So notice how my point is below the line. That means it is unsaturated. So unsaturated solution. Okay. That's really all you had to say. We have this question again. In terms of bonds, why energy is absorbed? Energy is absorbed to break bonds. Needed, required to break the bonds. Okay, we've got this again. Wow, this is the exact same question. This is a bad worksheet. Sorry. Well, anyways, practice. Strontium salt emits colored light. Electrons release energy and return to ground state, giving off colored light. Okay. Charge distribution, why is it polar? Do you remember? Do you remember from earlier? So you're talking about asymmetry. So you can say asymmetrical charge distribution. You can say uneven charge distribution. But you really can't say anything like asymmetrical molecule shapes. You need to talk about charge distribution. And here's the answer key. So again, I'm sorry there were some repeats on that, but you know what? More practice, the better. If you have any questions, please reach out. Thank you.